This is a video on binomial probabilities. The question states, 54% of the U.S. population supports a high-speed rail network. If 17 Americans are randomly selected, find the probability that, first, exactly 9 support the high-speed rail network. Second, at most 9 support the high-speed rail network. Third, more than 6 support the high-speed rail network. And fourth, between 8 and 11 support the high-speed rail network. So let's go to our calculator. So here's the calculator. Since the survey question is a yes or no question, we're in the realm of binomial distributions. And since we want the probability of exactly 9 supporting, we're going to be in the binom PDF distribution. So on my calculator, I'm going to hit second, distribution, or distr, and then I'm going to scroll down a lot until I get to the binom PDF. And there it is, it's on A in this calculator. So I hit enter, and the syntax is the sample size, comma, the probability of success, comma, the x value. The sample size here is 17, so I hit 17, and then comma, the probability of success is 0.54, so 0.54, comma, and our x value is 9. And the parenthesis, and I hit enter. So we can say that the probability that exactly 9 will support the high-speed rail network out of the 17 that were surveyed is 19%, or 0.19. So let's look at the second question. What is the probability that at most 9 support the high-speed rail network? So here we want the probability that x is less than or equal to 9. Notice at most 9 is the same as less than or equal to 9. When we have a binomial question and we want the probability that x is less than or equal to a number, we use the binom CDF function. So I hit second, distribution. It's a little faster to use the up arrow to find it. And there's binom CDF. I hit enter. And the syntax is the same. So we had a sample size of 17, comma. We had a probability of 0.54, comma. And we want to find out the probability that x is less than or equal to 9. So 9, and end the parentheses. And I hit enter. So I can say that the probability that out of these 17 Americans, at most 9 support the network is about 56%, or 0.56. So now let's answer the third question. We want the probability that more than 6 support the high-speed rail network, or the probability that x is greater than 6. The calculator doesn't handle binomial probabilities for greater than, so we have to use the rule of complements. So that tells us we can type in 1 minus the probability that x is less than or equal to 6. So again, I go to second, distribution. I find the binom CDF. Then we have 17, comma, 0.54, comma, and then 6. Then end the parenthesis. I hit enter. And that probability is about 90%. So there's about a 90% chance that of those 17 Americans, more than 6 will support the network. Okay, finally I want the probability that x is between 8 and 11. And I'm considering between to mean between 8 and 11, including 8 and including 11. So to do this, because again, the calculator doesn't handle between questions, so we have to get a little sharp on that. We can say that the probability that x is between 8 and 11 is equal to the probability that x is less than or equal to 11 minus the probability that x is less than or equal to 7. So I'm going to hit second distribution and then scroll up until I find binom CDF, hit enter. 17, comma, 0.54, comma, so 11 will give me the probability that x is less than or equal to 11. And then I subtract, so I hit minus, I subtract the probability that x is less than or equal to 7. So second distribution, I'm going to do a binom CDF again. Hit enter. 17, comma, 0.54, comma, 7. And I end the parenthesis and hit enter. So I can say that if 17 Americans are randomly selected, then there is about a 66% chance that between 8 and 11 of them support the high-speed rail network. And I'm done with the problem.